In this lesson, we are going to go through a topic that you've learned since year 3, year 4, but combining with a GCSE higher end topic, trigonometry. So, area of triangles with trigonometry. Um, we're going to learn how to find the area using of triangle using sine, a different formula, and then we're going to learn how to apply trigonometry in area of triangle and to work backwards and to apply sine and cosine rule in the area of triangle. So the area of triangle, apart from what you've learned in the basic primary school stuff, half base times height, we're not going to use that unfortunately. So we're going to use a different variant for the area of triangles, which you need to know. Um, Right, so have a go. Speaking of trigonometry, have a go at starter questions using a calculator, sine rule, cosine rule, SOHCAHTOA, work out the value of x. Okay, round your answers to one decimal place. When you're ready, you can press play. Here are the answers. Question A, you need to use SOHCAHTOA sine, part B, cosine rule, and C, sine rule. If you need help with any of these single questions, please go back to previous videos on SOHCAHTOA or cosine rule or sine rule. May I introduce you to the advanced version of the area of triangle formula, half AB sine C. Right, so this formula is the advanced one because you're going to come up from the half base times height version, which you've learned in primary school, where the heights must be perpendicular. Now explain why this is a superior version than this, because essentially they are the same thing, but this half AB sine C could be applied to all kinds of triangle. Okay, right, so there one thing that you do have to remember about using half AB sine C, which is the sine C, the C angle, must be between the length A and B, like an idiot sandwich.
What are you? An idiot sandwich.
So you'll be thinking, how is this superior than half base times height? Are they different? They are actually the same. Why? Because if you think about half base times height, you have to use that's the base, that's the height. Half the base, imagine that's B, imagine I change the height into A. Okay, so that will becomes half using this formula AB sine C. What's a C angle? C angle is a 90 degree. And if you know your exact value of trigonometry, sine 90 equals to, well, it should be telling me, yes, 1. So sine 90 is the same as 1, so that's the same as half A times B. That's the same as half base times height. Therefore, half AB sine C literally is the area of triangle, bar none. Half base times height is just for kids. Damn! Let's start off with some examples. I'll show you how to use the formula. So the first example, work at the area of the triangle. Well, we see a 12 centimeter, 18 and 40 degree. So the formula you should be recalling is area equals half AB sine C. Now, even though that looks at right angle, you can't assume it's a right angle unless the question tells you so. You can't really assume that's a right angle. Right, so half AB sine C, so that will be our A, B, and that will be our C angle. It doesn't matter which one is A, which one is B, so E equals to half times 12 times 18 sine 40 degrees. If you put in a calculator, make sure your calculator is in degrees mode. You can see there's a D on top of the display. It says display degrees mode, so make sure it's in degrees, otherwise you get wrong answer. And then you get 69.4 centimeters squared. I rounded to 3 significant figures. Okay, right, next one. Work out the area of a triangle. This is a scalene triangle, so first thing you should come to mind is using half AB sine C when it comes to area of triangle. Basically, if you don't see a right angle, you don't use half base times height. You should be using half AB sine C. Right, so, but to use this formula, we need an angle. We don't have an angle. So which angle should we find? We've got 1, 2, 3. Which one should we find? The answer is it doesn't matter as long as you can find one. Now, however, based on the angles you found, the A and B used in the equation in the formula will be different. Okay, because remember, A and B has to be next to the angle. Let's say we try to find this angle on the far right. Okay, so I need to find this angle, so I'm going to use cosine rule to help me find out that angle. So to work on the angle, I'm going to use cos A equals B squared plus C squared minus A squared over 2BC. So if that's my angle A, so 5 will be my A, B, and C. So cos A equals to 10 squared plus 7.5 squared minus 5 squared over 2 times 10 times 7.5. Now, I know it's quite tempting to put that in a calculator and get a nice fraction, but you could save some time by making A the subject first, so by inversing cos on the other side and put that big chunk of a monster fraction in the calculator, and you'll get a 28.955 degrees. I wrote a couple of decimals, 3 decimal places, mainly because I know I need this angle for the next step. So the more decimal places I write in here, the more accurate it will be towards the final answer. Next step, I can work out the area. So the area equals half AB sine C. Now, this will be my C angle. Now, just don't get mixed up. The A and B in here is not the same as the A and B used for the cosine rule. The A and B here refers to the A and B next to the angle that you've chosen. So this will be my new A, this will be my new B. So equals half times 10 times my new B, 7.5, new B. Well, sine C, sine 28.5 degree, 55 degree, and then you will get a 18.2 centimeters squared, 3SF. You know what time it is. It's practice time.
Yeah, boy.
Your turn to have a go at a question. When you're ready for the answer, you can press play. Here are the answers. On the top, I gave you the final answers for question A, B, and C, so you can check it first. And then if you got all of them correct, well done. Move on to next one, next bit. But if you need help, here's A and B. A and B are more like a previous example I've showed you, so I'm not going to go through any more. But part C, some students I know you might find a bit more difficult, so I'll go through it with you. Now for part C, to work out the area of a triangle, you need half AB sine C. But you can't quite use a 20 degree in here. Reason being is that 20 degree is not between the two lengths 50 and 9. So there are two options you can do, okay? Two routes, okay? One is to work out this value here, let's say x. Then we can use half times 15 times 9 times sine dx angle. The other option is, which I'm not going to go through, is to find this length in here. Let's call this L. Then you can use area equals half 15 times the length here, sine 20 degree. You can use cosine rule to work out this one, but I'm not going to go through that. I'm going to work out the x instead because it will allow me to cover some bit of sine rule, just do a bit of recap with you as well. So first, to work out that angle x, I can't help but to work out this theta, this angle first, because if I can work out that theta value, I can work out x. Well, why do we need to find theta? Can we not find x immediately? Well, the answer is no, because we don't know this length. If only sine rule, I need to know this length, the opposite length to x, before I can use sine rule to work out x. So therefore, sine rule, I can only work out theta. So here we go. So sine rule first. So sine rule to find theta. So that's the first step. So sine theta, if I want to find theta, I'm going to use the put the angle on the top of the sine rule. So sine theta over 15 equals sine 20 degree over 9. So sine theta equals sine 20 over 9 times 15. So theta equal inverse sine the whole thing of the sine 20 over 9 times 15. So theta will give me 34.75 degrees if we put in a calculator. However, if you have watched the sine rule video, you remember one special case I mentioned. The words start from A. And remember? It's called ambiguous case. Now you can see theta value is clearly an obtuse angle. So we have to apply the ambiguous case trick in here. Ambiguous case. So which is 180 degree minus the acute angle. So that will give you 145.25 degree. That's the angle of theta. Okay, so theta equals 145.25 degree. Therefore, x will equal to now 180 degree minus 20 degree minus 145.25 degree. Angles in a triangle at 180, so that's what I'm doing in here. So that equals to 14.75 degree. That's the angle for x, and therefore the area equals to half 15 times 9 sine 14.75, and that equals to 17.2 centimeters squared. Here comes practice question 2. This time you have to work backwards given the area. So pause the video, have a go at the question. When you're ready for the answer or when you're ready for help, then you can press play. Here is the answer. A, x is 35 degrees and B is 115 degrees. If you want me to explain to you, you can continue the video, otherwise you can move on. So question A, I know the area is 0.55, so I'm going to set an equation which equals to 0.55. So half A B sine x equals 0.55. What I can do next is I can put this chunk in a calculator, and that will give me 0.96. So 0.96 sine x equals 0.55. Now remember, x is attached to sine, so what you have to get rid of first is a 0.96. I'm going to divide to right hand side, so 0.55 or put 0.96. It looks a very clunky equation, doesn't matter. What you have to do is just to inverse it, inverse sine of it, and then you get 35 degrees. Next, part B. Same thing, half 10 times 8.5 sine x equals 38.5, not 35.5 degrees, 38.5. So half times 10 times 88.5 is 42.5. So 42.5 sine x equals 38.5. Sine x equals 38.5 or 42.5. X equals inverse sine it, and you'll get 64.9 degree. But x is obtuse. Again, ambiguous case. So because x is obtuse, so therefore x equals 108 degree minus 64.9 degree, which is, because you have to round to nearest integer, read the question, so 115 degrees. Last but not least, practice question 3, a little bit of complicated triangle, more than one triangle in here. Have a go at the question, work out the area of the triangle ABC and give your answer to nearest integer. Pause the video, have a go at the question. When you're ready for the answer, or if you have no clue, play the video. The final answer is 334 centimeters squared. First of all, there are actually lots of ways to work it out. Okay, to work out the whole area of triangle ABC, you should be using half AB sine C at some point towards the final answer. Now, I'm going to present you one way to work it out. Okay, so what I'm looking to do is I'm looking to work out the length of AC. Like if I can work out AD, then I know DC as well, so I can work out AC. And I work out the length of BC, then that will be my half AB sine 77 degree. Now to work it out, I've got a couple of things to do. First of all, I realize this angle BDC equals 180 degree minus 26 minus 77, which is actually 77 degree. If you have to give reason, that will be angles in a triangle. So that will be 77 degree. Next, to work out the length of BC, I can use sine rule. So I'm going to work out length of BC. So I'm going to call BC. So BC over sine 77 degree equal 10 centimeters over sine 26 degree. So BC equals 10 over sine 26 times sine 77, which gives me 22.2270571. As I said, reason I write in full is because I might need it later. Okay, so BC equals that one. Now what I realize is angle BDC and angle BCD, they're both 77 degree. So what kind of triangle does it tell you? And I source this triangle. So what I know is basically these two are the same. So if that's 22.2 something, this will be 22.2 as well. Okay. Right. So I found BC. I've got BD. Next thing I need to work out is the length of AD. To work out length of AD, I know this angle is 103 degree. So angle BDA, I'm going to use a different color to show you a different stage of working. So angle BDA is 180 degree minus 77 degree, which is 103 degree. The reason being is angles on a straight line. Now you can use this kind of symbols in the real exam, angle, straight line. These are like universal ones, so you can use them. So angle straight line 103 degree. The question didn't ask you for a reasoning, but sometimes in a harder question like this question could have worked 5 marks and asked you to work out all the, show you all the working, give a reason for every step. So these are things you have to do. Anyway, to work out this length of AD, I've got this 22.2. To work out this length, what can I do? Well, I can use sine rule, but to use sine rule, I must know the opposite angle. So this opposite angle, so angle ABD equals 180 degree. In another triangle, 180 degree minus 40 minus 103, that will give me 37 degrees because angles in a triangle again. Okay, so that will be 37 degree. So sine rule. So if I call AD, so AD over sine 37 equals this 22.2. So 22.2, I write 22.2 in here, but in my calculator, I'm going to use the full value over sine 40. So AD equals 22.2 over sine 40 times the sine 37 degree, which will give me 20.8102597. So 20.8. And last but not least, I can then work out my final answer. What color have I not used? Let's use purple. I've not used purple before. So therefore, my final answer, the area equals half. My A is my AC, whole length of AC, times B, BC. So half AB sine the angle C, literally C, 77 degree. So my AC is 20.181 plus 10. So it'll be half of 20.8 plus 10 times BC, 22.2 sine 77 degree. Now remember 20.8 and 22.2, I'm going to use the full value. So once you've got everything, you plug in the calculator, you will get the answer 334 centimeter squared.